for this FRQ it says let f equal sine of x squared plus cosine of x. The graph of y equals absolute value of the fifth derivative of f is shown over here. Part A says write the first four non-zero terms of the Taylor series for sine about 0, and write the first four non-zero terms of the Taylor series for sine of x squared about 0. So here's the formula for sine. We have sine equals sigma n equals 0 to infinity, negative 1 to the n, x to the 2n plus 1 over 2n plus 1 factorial. Remember that sine is going to be your odds versus cosine is going to be your evens. So we're going to write sine out to get those first four non-zero terms. First, we're going to plug in 0 for all the n's. When you plug in 0 here, you get 1. When you plug in 0 right here, you're just going to get x. And when you plug in 0 right here, you get 0 plus 1, or just 1 factorial. 1 factorial is 1. Plugging in a 1 right here, you get a negative term. When you plug in 1 right here, you get x cubed. When you plug in a 1 right here, you're going to get 3 factorial. And we'll just continue doing that. Okay, so here's the first four non-zero terms for sine. You have x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial. So right here, when you have sine of x squared, it's a composition of functions, so you can just think of taking this x squared and plugging it in for any x that you see in the original sine series. Okay, last step, we're just going to simplify everything and then we'll have our answer. And here's the expression for sine of x squared. You get x squared minus x to the 6th over 3 factorial plus x to the 10th over 5 factorial minus x to the 14th over 7 factorial. And it keeps going, but these are the first four non-zero terms. Part B says write the first four non-zero terms of the Taylor series for cosine of x about x equals 0. Use this series and the series for sine of x squared found in part A to write the first four non-zero terms of the Taylor series for f about x equals 0. F is defined as sine of x squared plus cosine x. So we'll take the two expressions and then add them together. Okay, so cosine is sigma from n equals 0 to infinity, negative 1 to the n, and then right here for cosine you have evens, so you have x to the 2n over 2n factorial. And now we're going to write cosine out. To start, we're going to plug in 0. When you plug in 0, you just get positive. When you plug in 0, it becomes x to the 0, which is 1. And right here, when you plug in 0, you get 0 factorial, which is just by definition 1 as well. When you plug in 1, you get a negative. When you plug in 1, you get x squared and then 2 factorial. And when you continue, you get even powers and then you get even factorials in the denominator. Okay, we're given that f of x is equal to sine of x squared plus cosine of x. So we're adding sine of x squared to cosine of x and want to think of it as combining like terms. So here you just have a constant. Here are your terms with x squared. There's only one term with x to the 4th, and then these terms both have x to the 6th. So here's the expression to start for f of x. You have 1 plus, and then here's the terms that have x squared in them. There's only one term with x to the 4th, and here's the x to the 6th term, so now we just need to add up the like terms. Okay, so for the x squared terms, this is 2 factorial or just 2, so that means we want to make common denominators, so this term needs to be multiplied by 2 over 2. I just dropped down the x to the 4th. And then for x to the 6th, this has 6 factorial and this has 3 factorial. So to make common denominators, we'll need to multiply this by 6 times 5 times 4 on top and bottom. And then finally, let's just simplify it all up. So here's our final answer for f of x. It's 1 plus x squared, and then instead of writing 2, I wrote it as 2 factorial just to stay consistent with these last two terms, plus x to the 4th over 4 factorial. And then you get negative 121 x to the 6th over 6 factorial. Part C says find the value of the 6th derivative of f at 0. To find the coefficient of the x to the 6th term, it's going to be the derivative on top divided by 6 factorial. And again, that's straight from the formula for a Taylor series. So here's our formula for f, and if we focus in on this x to the 6th term, you have negative 121 over 6 factorial. So when we set these equal to each other, you see that the 6th derivative of f at 0 is going to equal negative 121. All right, so you get negative 121. Part D says let p sub 4 of x be the 4th degree Taylor polynomial for f about 0. Using information from this graph right here, this is going to be the Taylor polynomial minus the actual function where 1/4 has been plugged in, and we just want to show that that error is less than 1 over 3,000. So since our Taylor polynomial is taken out to the 4th degree, we look at, for error, the next term, which would be the 5th derivative over 5 factorial to the 5th. And if you look right here, you have 1/4 is being plugged in. So we're going to plug in 1/4 for x. Let's look at the graph for the 5th derivative. So if you look over here, right here would be 1/4. And if we go up to the graph, you can see that the height of the graph at 1/4 is clearly less than 40. So we're going to use the value 40 to plug into our expression down below. We're going to plug in 40 right here to make this inequality. So 5 factorial is 120, and then I just brought this 4 to the 5th down, and then I have 40 on top. 4 to the 5th is 1024, then we multiply 3 and that, and we get 1 over 3072, which is going to be less than 1 over 3000.